Hello students, this video lecture is going to cover section 5.5, factoring trinomials. Our objectives for this video lecture are to recognize and factor perfect square trinomials and be able to factor trinomials of the form x squared plus bx plus c and ax squared plus bx plus c. So first, remember that we've done this in the opposite direction already. We've already looked at FOIL of perfect squares. So remember that these formulas are things that we've seen previously. So let's take a look at how to use them in this way. Here we have a couple examples of perfect square trinomials. Now this method only works if it is a perfect square trinomial. But what I want to look at is I want to look at this first piece, and I want to remember that this is going to be u squared. I want to look at this last piece, and this is going to be v squared. Now in this case, I have plus 2 times u times v. So here, if u squared is equal to x squared, then I know that u has to equal x. If v squared equals positive 4, then v has to be the square root of 4, which is going to be 2. The term that I'm really concerned about is this 2 times u times v. So I want 2 times u times v to equal what it is in the question, or 4 times x. So I check this compared to what I know. I take 2 times u, which I know is x, times v, which I know to be 2. So I have 2x times 2, which is 4x. So in this case, since this middle term is in fact 2 times u times v, I can write this as u plus v quantity squared. In other words, my final answer is going to be x plus 2 quantity squared. So moving on to the second question, the first thing that people want to try to do is they want to say, oh, well, it's a perfect square trinomial. So 5x squared equals u squared, and u equals, and the problem here is this 5. Now this is not the method that we want to get used to using. What we want to do first is we want to get in the habit of always looking for a greatest common factor. In this case, the greatest common factor is 5. So when we factor the 5 out of this polynomial, we get x squared plus 6x plus 7. Now if I look back to my rules for perfect square trinomials, I take a look at this question and I confirm this first term is in fact a perfect square. We have x squared. And I look at the back term, and 7 is not a perfect square. So in this case, I cannot use perfect square trinomials for this question. Now there is another method that we'll start to use momentarily. Just realize that you cannot use perfect square rules if you don't have perfect squares. So you have to go to something else. So that something else involves factoring trinomials of the form x squared plus bx plus c. Now, I'll be honest, this can be a little bit tricky for people, but what we want to do is when there is no leading coefficient, so in other words, there's no number in front of the x squared, we want to look at this number that's in the absolute back position. So we want to look at c. In this case, c is -4. And we want to write all of the possible ways that we could make -4. So I have -1 times +4. I have -2 times +2. And I have -4 times +1. Once we have all of the pairs, we want to look and add them together. So we're going to take the sum of the pairs and we're looking for b. And the b that I'm talking about is this b. So we're looking to make -3. In this case, this is the pair that would give us -3. So this takes us to our answer. We know that x squared is going to be broken out as x times x, and these numbers are the numbers that are going to go into the multiplication. So we take the -4 and the +1. Remember, we can always check our answer to see if it's correct. So don't be afraid to check your answer. So let's try another example. What we do is we take the last number, the -8, and we look for all possible pairs. We have -1 times 8. We have -2 times 4. We have -4 times 2. And we have -8 times 1. We take these numbers and add them together, and we're looking for that middle term. We're looking for that b. So this is the pair that's going to give us +2. So we use x minus 2 times x plus 4. This is the final answer. But remember, you can always check your answer to make sure that it's correct. If I FOIL, I get x squared. Outer times outer gives me plus 4x. Inner times inner gives me minus 2x. And last times last gives me -8. Combining these like terms in the middle gives me x squared plus 2x minus 8. If when I FOIL, I get back to the question, I know that my answer is correct. In this example, we're looking for +6. So I take +6 and I write it as 1 times 6, or it could be 2 times 3. Now, when I have a negative in the middle and a positive on the back side, I want to add these together, but if I add them together in their positive forms, I will never get a negative number. So I have to make both of these negative in order to get a negative number when I add. So -1 plus -6 is -7, and -2 plus -3 is -5. So this is the pair of numbers that I'm looking for. So I have x minus 1 times x minus 6. So let's take a look at a couple clues that we have here. We have +96, but our b value is negative, so we know that we're going to have two negatives. Now, you could start at 1 times 96, make them both negative, but when we add these together, we're going to get -97. And that's pretty far away from -20. I could have -2. If I'm going to take -2, then I have to multiply by 48. And so this is going to give me -50. 3 goes into this. 3 is going to go in 32 times. So that's going to give me -35. We're getting much closer, and you can see as I work my way down, I'm getting closer and closer to that value of -20. -4, that's going to work. I'm going to add that to -24. That's -28, getting closer still. negative 6. That's going to be times negative 16. That's going to give us negative 22. Much closer now. And finally, we're going to have negative 8 times negative 12, which is going to give me that result I'm looking for of negative 20. So this is the pair that I'm looking for. Now you can see once I find the pair that I'm looking for, I'm going to stop working, and I'm going to write my answer as x minus 8 times x minus 12. Again, you can FOIL this out to check and make sure that you've got the correct answer. Now there's a slight change here that's very important. At this point we have a number in front of the x. So this is going to change the method. Instead of just looking at c, which we've been doing previously. So we have just been looking at c. At this point, now that there's an a, we want to take that a and we want to multiply it by the c. So we're going to take 4 and multiply it by negative 6. So now we're looking at negative 24. So this is going to add a step to our process. So we take negative 1 times 24. That would give us 23, which we're looking for 2. We could have negative 2 times 12. That's going to give us negative 24 by multiplication, positive 10 by addition. Negative 3 times 8 would give us positive 5 by addition. We have negative 4 and 6. And that's the pair that's going to give us positive 2. So this is the step that's now added. These numbers are not our answer. So previously we've been able to go straight to the answer. We would have written x minus 4 times x plus 6. The problem is now we have to use these numbers and write this as a 4-term equation. So we're going to write this as 4x squared minus 4x plus 6x minus 6. So you can see the minus 4 goes for one and the positive 6 goes for the other. And this 2x is really the same thing as this term. We have uncombined the like terms. Now you have to go back to what we learned in factor by grouping. We're going to look at this first piece and we're going to factor out the greatest common factor, which in this case is a 6. That would leave us with x minus 1. We take this x minus 1 and move it to the front. In order to do that, we're going to have to factor out a 4x here. Now we just have to determine the sign. And in this case, it's going to be a plus sign. We take our common binomial factor out, the x minus 1. And by taking those out, you can see the leftover portion is 4x plus 6. And so this is our final answer. Let's take a look at another one of those. We take a times c. So we have 2 times negative 4, which is going to give us negative 8. We look at all the pairs of these and we're trying to add them up to get negative 7. So we have negative 1 and 8. That gives me positive 7. Now that's a good sign. The number's correct, but the sign is wrong. So instead of writing anything else, I'm going to go immediately to negative 8 and 1. And that's going to give me the number that I'm looking for, the negative 7. I'm going to uncombine the middle term. So I'm going to write this as 2x squared minus 8x plus 1x minus 4. So this middle term has now been uncombined. There is no common factor, so I know that I'm going to get x minus 4 as my common binomial. So if I look at 2x squared minus 8x, 2x squared is going to be 2 times x times x. 8x can be written as 2 times 2 times 2 times x. I want to take an x off of the first one, and I want to take a 4 off of the back one, so 2 times 2. And so you can see the remainder here is 2x. So that's what goes in the front. The only way to get this to multiply out correctly to give me positive x minus 4 is to put a plus 1 here. So our common binomial factor is x minus 4. And if I take that off, I'm left with 2x plus 1. So this is my final answer. Let's take a look at one last question. This is now kind of the culmination of everything we've done in this section. The first thing that I want to do, and this is a habit that we should be in, is to look for the greatest common factor. So I have 8m to the third n, which can be written as 2 times 2 times 2 times m times m times m times n. 20m squared n squared. That's going to be 2 times 10, which is 2 times 5, 2 m's, and 2 n's. 48m n to the third. That's 2 times 24, which is 2 times 12, which is 2 times 6, and 6 is 2 times 3. 1m and 1, 2, 3 n's. Now they all have a 2. In fact, they all have a second 2. I'd love to take another 2 out, but 20m squared n squared has no 2's left. While 20m squared n squared has a 5, none of the others have a 5, and 48m n to the third is the only term that has a 3. They do, however, all have at least one m and at least one n. So our greatest common factor is going to be 4 times m times n. So let's rewrite this with the greatest common factor pulled out. We have 4mn times the trinomial. We have 2 times m, so that's 2m squared. We keep the plus sign, so plus 5mn we keep the minus sign. 2 times 2 times 3 is 12, so we have 12n squared. Okay, so we have a coefficient here, so we're going to take the 2, multiply it by the negative 12. We end up with negative 24. And we're looking for a sum that's 5. So we have negative 1 and 24. That's going to give us positive 23. We have negative 2 and 12. That's going to give us positive 10. We have negative 3 and 8. And that gives us our positive 5 term. So we're going to work our way up now. We keep the 4m times n. And we're going to break that middle term apart. We have 2m squared minus 3mn plus 8mn minus 12n squared. So I've used these numbers to break apart this middle term. And I'm working my way up. These back two pieces, they share a 4 and they share an n. So we're going to factor out a 4n and determine what's left over. Well, it looks like we're going to have 2m in the front, and in the back we're going to have minus 3n. So remember, we have to use that same thing in the front. So we have 2m minus 3n, and we have to figure out what's left over, and it looks like there's just an m here. M times 2m would give us the 2m squared, and m times negative 3n would give us the minus 3mn. With a positive and a negative, it looks like this 4n needs to be positive. And this whole thing, don't forget, is being multiplied by 4 times m times n. So now let's write our final answer. We keep the 4m times n. That's the common monomial factor. We take out the common binomial factor from inside the brackets. That's the 2m minus 3n. Once that's gone, we can see that what's left over is the m plus 4n from the inside. M plus 4n. And this is our final answer. Take some time, FOIL this out, multiply it by the common monomial factor, and see if you can get back to the question. And that concludes this video lecture on section 5.5.